Hello dear friends, welcome to the lecture of mechanics. In this lecture we shall solve some multiple choice questions on mechanics, and in mechanics we shall solve the questions on statics, part of mechanics, which is statics, and the topics will be forces acting on a particle, forces acting on a rigid body, equilibrium of forces, laws of forces, parallelogram law, triangle law of forces, moment of force, couple of forces, and center of gravity, etc. So, I have written a few questions here. I will suggest you to take a screenshot of this, attempt these questions, write your answers and then verify the answers. The instruction is choose the correct alternative. 4 alternatives are given and we have to select the correct one. First question is if the force P bar makes an angle theta with line OX, then the resolved part of P bar along the line OX is resolved part of force P bar along line OX. So, what will be that? So, if you consider force P and making an angle OX with some line, suppose this is the line OX, may be taken as x axis, and if the force is this one, which makes angle theta with OX, then the resolved part of this force along OX is given by P cos theta, P into cosine of angle made by the force with the line, that is resolved part along OX. And if you consider the perpendicular to OX, which may be denoted by OY, then the resolved part of P along OY in terms of this angle theta will be P sin theta. So, this is along OX and this is along OY. But here it is asked along OX, and therefore the correct answer is P cos theta. Next one, the resolved part of the force R along the direction of unit vector E bar is. So, what will be that? So, this is dependent on the same. Now, the unit vector is E bar. Instead of the line OX, we may consider the unit vector along the line OX as E bar. Now, what is the resolved part of this along this unit vector E bar? That will be given by the dot product of P and E. So, why? Because we know by definition of dot product, this is magnitude of P, which we denote by P, magnitude of E bar. E bar is unit vector and therefore it is 1 into cosine of angle between P and E bar, that is theta. So, which is same as P cos theta, if theta is the angle between P and E, and therefore here it is dot product of the force with the unit vector along which the force is to be resolved. Here, if the force is to be resolved along OX, it is P cos theta, and the same result can be written in terms of the dot product of P and E. But here, see, the force is given as R. If the force is R, then that will be R dot E. So, the B is the correct alternative. Next is if C is the midpoint of AB, then resultant OC bar of forces OA and OB is given by. So, this is the result that we have obtained, and it is a special case of that result. See, if AB is a line or segment, if this is AB and OE is any point, say here, then we have to consider the resultant of OA and OB. So, join OA, if you join OA and OB, and this will be OB. See, OA and OB. Their resultant is given in terms of the midpoint. Suppose the midpoint of AB is here, C. Then if you join OC, this vector, then the result, when the resultant will be OC, the relation between these is OA, OB and OC will be of this type, OA plus OB and that is equal to twice OC. So, how to verify this? If you can consider OA and then plus AC. So, what is OA plus AC? That is O to A to C, that is OC. Similarly, what is OB plus BC? OB plus BC, O to B, then B to C is again OC by triangle law. And if you add it, so if you add it, then what we will get is OA plus OB. Now, what about AC and this is BC? Because C is midpoint of AB, AC and CB are equal and opposite, they cancel and we get the right side as twice of OC. So, therefore, this is the correct result between this OA, OB and OC, and thus the correct alternative is D here. Next question is the angle between two equal forces P bar when their resultant is again P bar is given by which? So, equal forces are there and their resultant is again the same force P. So, we know that if P and Q are two forces and R is their resultant, then R is given by, so that force R is given by, R is equal to under root of P square plus Q square plus 2PQ cos theta. If theta is the angle between the forces. Here all are equal. Here P is equal to Q is equal to R, and that means we replace each by R. So, therefore, we will get each by P. P will be, R is P, Q is also P. P is under root of, this will be P square plus P square plus here it is 2PQ cos theta. So, that is 2 P into P, that is P square into cos theta. Now, when this will be equal, if this cos theta or this quantity is P square only, and that means this must be cos theta must be minus half. So, then if it is minus half, then it will be P square plus P square minus P square, and that is P square. So, this implies cos theta is equal to minus 1 by 2, and if cos theta is minus 1 by 2, what is theta? So, we know that cos of 90 plus 30 is equal to whenever the angle is allied angle formula, cos of 90 plus theta, cos becomes sine, and this is the second quadrant cosine is negative. So, it is minus sine 30 and minus sine 30 is minus half. So, therefore, cos theta is minus half implies this angle theta is 120. So, therefore, theta is equal to 120 degree, and thus using this relation we have obtained. You should verify this. This must imply cos theta is minus half and half, that is minus P square, and P square plus P square minus P square means root of P square, which is P. So, this implies cos theta is minus half, and that implies theta is 120, and therefore, the correct alternative is here C. Next one, if any number of forces acting on a particle be represented by sides of a polygon taken in order, then the forces are what kind of forces? Equal, opposite, in equilibrium, non-coplanar. So, if forces are represented along sides of a polygon taken in order, that means if this is a polygon, say having any sides, any number of sides, then the forces are given as, say, suppose this is A, B, C, D, E, F. Then the forces will be the P1 along AB, P2 will be along BC, P3 will be along CD, and this is P4, and so on. If these are the forces are like this, maybe polygon having here we have drawn it is along having 6 sides, and may be having 4, 5, etc., or more number of n number of sides, and but the condition is the forces acts along the sides of polygon taken in order in the same sense of direction. Then these forces, this is a result, we have studied equilibrium of forces. These forces are in equilibrium, and this is the correct alternative. Next is, if two forces of magnitude 6 kg and 8 kg at an angle 90 degree, what is the magnitude of their resultant? So we can use the earlier formula, that is the magnitude of their resultant is given by p square plus q square plus 2pq cos theta. And here the values of p and q are given as 6 and 8. Therefore, this will be under root 6 square plus 8 square plus 2 into 6 into 8 into cos of angle here is 90, cos 90, and we know that cos 90 is 0. So, therefore, this term vanishes, and what remains is root of 6 square is 36 and 8 square is 64. 36 plus 64 is 100, and therefore it is 10. So, this is the formula that we have used, and the correct alternative is A. Next one, the forces PQ are acting on a particle at a point are in equilibrium. Then, which one of this is true? Forces are in equilibrium means their resultant is 0, and their resultant is always obtained. Resultant of number of forces is always obtained by taking vector addition of the forces. So, resultant of P1, P2, Pn forces will be sum of the forces, P1 bar plus P2 bar and so on up to Pn bar. And here the three forces are there, their resultant is P bar plus Q bar plus R bar, and that must be 0 because these forces are equilibrium. Resultant is obtained by summing the forces, and if they are in equilibrium, the sum, vector sum is 0, and therefore the correct alternative is this one. P plus Q plus R is equal to 0 vector. Next one, two equal, unlike and parallel forces acting at different points of a rigid body forms what? That is actually a definition of two equal, unlike parallel forces. Suppose this is a rigid body and two equal forces acting at different point. Two equal, parallel and unlike. So, the forces are like this. So, they will have the equal magnitude. So, this length we have to assume is same as this one, and they are parallel but unlike, means having opposite direction. So, they forms a couple. So, this is a couple, definition of couple. So, equal, unlike, parallel forces acting at different points. So, these are the conditions, form a couple. Next one, three like parallel forces P, Q, R act at the vertices of a triangle ABC, and if their resultant passes through in center, then which result is true? Actually, this is a problem. Suppose the triangle is ABC and the forces are the forces are like parallel forces act at the vertices. So, that means this is force P may be denoted like this, force Q parallel to this one acting at B, and force C is R. P, Q, R are the forces. Then their resultant passes through in center of this triangle. So, suppose this is the in center, and the resultant, their resultant will pass through this in center. Then what is the relation between these forces is what is P upon A? What is small a? Small a is the side BC. Opposite to vertex A, the side is denoted by small a. Small b is the side AC. Opposite to vertex B, the side CA is denoted by small b. And similarly, the side AB opposite to vertex capital C is denoted by small c. And if the resultant passes through in center of the triangle, then the result, this is a problem, and the result is P upon A. These quantities are in proportion. Magnitude of force P divided by the side, opposite side to this vertex A. P upon A is equal to Q, the force Q divided by B is equal to the force R divided by C. And therefore, this is the correct alternative for the 9th question. These are the next questions. Again, I would like to suggest you that take a screenshot of this, write your answers and then verify the answers. The 10th question is, the effect of a couple acting on a body produces what type of motion? Only a motion of rotation, only a motion of translation, both rotation and translation, and none of these. So, as we have seen, couple is formed by two equal, unlike and parallel forces acting at different points, and therefore they will produce a motion of rotation. So, that only motion of rotation will be produced, because if this is a rigid body and two couples will have the position like this, if F is one couple and another couple will be minus F, and they act at two different points, and therefore one force acts in this direction and one force acts like this, opposite direction, equal, unlike, parallel forces, and therefore effect of a couple will be always a type of rotation motion, and thus it produces only a motion of rotation. That is, A is the correct alternative. Next, two couples in two different and parallel planes are said to be equivalent if they possess the same moment, they possess different moments, they produce motion of translation, and none of these. So, two couples are said to be equivalent if they possess the same moment, and therefore by definition, and therefore A is the correct alternative. So, they act in different but parallel planes and are equivalent if they have the same moment. Next question is vector moment of force. The force is given I plus 2j plus 3k act at this point, about the origin is which one? So, here we have to calculate this, and we know vector moment of force is given by R cross F. Suppose a force acts at a point A, and this is the force which is given here as I plus 2j plus 3k, and it acts at a point, the point we may take as P minus 1, 2, 3, and its moment is asked about origin. Suppose origin is here, then the moment of this force is given by R cross F. Now, therefore, this is suppose this is vector moment, it is R cross F, and that will be the cross product of these two vectors. R will be having components minus 1, 2, 3, and F is given as 1, 2, 3, and therefore the vector product will be, first row is ijk in the determinant, the second row are the components of R vector, and the component of R vector is OP vector minus 1i plus 2j plus 3k. That means the components are minus 1, 2, 3, and next components of vector F, which is given here 1, 2, 3, and see the cross product of this the vector is at the expansion of the determinant, and that is I into 6 minus 6, that is 0, 0i, and then minus j, and the cross product minus 3 minus 3, that is minus 6, and plus k minus 2 minus 2, that is minus 4k, or which is equal to 6j minus 4k, and thus 6j minus 4k is the vector moment, and C is the correct alternative. Next is centroid of weighted point is. Now, what about the property of this centroid of weighted point? Does not exist, exists but not unique, exist and unique, none of these. And here by definition of centroid of weighted points, it exists and is unique, and therefore the correct alternative is exist and unique. Center of gravity of uniform rod is at its midpoint, one end, any point, no point. Uniform rod having the same density or thickness, and suppose this is AB is the uniform rod, so it must have the same thickness, or you may consider this as only AB is the uniform rod, then its center of gravity will be at its midpoint. If we because the resultant of this these forces which has the weight of the particles will act through this point, or if the rod is supported at the center, it will be balanced, and therefore C is the center of gravity, means center, or is the center of gravity is the midpoint. The center of gravity of a rigid body is unique, not unique, independent, and does not exist. Again, the center of gravity is unique, of a rigid body is unique. That is property of center of gravity. Then center of gravity of a uniform parallelogram is at which point? So if the parallelogram is uniform, having the thickness of these is the uniform or the same, then its center of gravity will be the point of intersection of the diagonals. So here will be the center of gravity, that is the midpoint of the diagonals, and therefore is at the not midpoint but the intersection point of diagonals, is at the point of intersection of the diagonals, and not midpoint, not any vertex, and therefore the intersection of the diagonals is the correct alternative. Centroid of a triangle is at the point of intersection. For a triangle, the centroid is the point of intersection, is the point of intersection of the medians. See, this is ABC triangle, and medians means if you join the midpoint and the opposite vertex, then that will be the median, and these are concurrent, and this point is known as the centroid of the triangle. So here it is medians. Medians, the point of concurrence or intersection of median is centroid. Next is if ABC are the lengths of sides of opposite lengths of sides opposite to the angles ABC respectively of triangle ABC. So if you consider the same triangle, then here small a is the length of side BC which is opposite to vertex A. Small b is the length of the side CA which is opposite to B, and small c is the length of side AB. Then this is a rule which is known as A upon this side A, BC divided by sine of angle A is equal to this side B divided by sine of angle B is equal to side C means AB divided by sine of angle of capital C here. These are all proportional, and this is known as which rule? Sine rule, cosine rule, Lami's rule, tangent rule. So the correct alternative is sine rule. And the next one is, if two forces P and Q are perpendicular to each other, then magnitude of their resultant is what? So forces are perpendicular, P is perpendicular to Q, and the angle will be 90 degree. So their resultant is given by root of P square plus Q square plus 2PQ cos 90. But we know that cos 90 is 0, and therefore the resultant will be root of P square plus Q square, and thus the correct alternative here is C. So we have solved few questions, multiple choice questions on statics, which include forces acting at a point, equilibrium of forces, center of gravity, etc. So thank you for watching this lecture.